All right, you know the drill by now. Get going. You had a couple problems like this in your homework where we give you ism. Roger that. Heath, be gone. Come on now. It's basically our tables from Friday. Make the table, do the work, show whether those three are solutions or not. Cool. Remember, you label it, say 1-8, show the work, close your noisemakers, but you still got to have the work shown for what you did. Okay. I want to know what you know. I don't care what your neighbor knows, so stop talking to them. Okay, tell me what you know. What is a solution to an equation? How do I know if it's a solution? Oh, Bella said you're cool to be in here.
Cool. I can sit here for 3 hours.
Yeah. Yeah. And there we go. Now we see people writing. Okay. Go and you know what's going on? Okay. Verbal assessment's a thing. I'll have you walk me through, and that'll be your daily quiz. I'll just write it down. Cool? All right.
I got the second problem, but the first one I'm confused about.
Got a calculator on hand?
Oh, no really?
There you go. You can have the calculator do the work for you. I don't care. Use your resources. I just want you doing it instead of your neighbor. Okay? Oh, if you run across any old brown border basics, they're mine. Love me a Mercadian Masks mountain. It's just stuff I was throwing in there. Well, good. Is there anyone still going? Well, I know you're typing right now, but anyone? Cool. So it's pretty simple. These are your x's. I'm going to find out if each of them is actually a solution. Not equals, minus. Okay? You can plug each one of them in and you find out, does it make this a true statement or not? So if I stick a -1 in there, what's 6 by -1? -6. You owe me $6. You borrow 4 more. Where are we at? Is that 0? Pretty sure it's not, so no. That one is not a solution. You try 2/3. If you have to go old school and say 6 times 2 over 3, 6 times 2, 12, 3 times 1, 3. 12 divided by 3 is?
4.
4 minus 4 is?
0.
Winner, winner. Okay. And try 0.8. If you got to grab a calculator, Cohen, what we got? Ow. You can't even do can't even do your phone with your right hand? Oh, that sucks. Okay. I had that problem going the other way, trying to do my phone with my left hand if I ever had my son and I was feeding him with one hand, like, and do one of these numbers. And, yeah, same thing. Ouch. Right? We get 4.8 minus 4 is 0.8. That's not a 0. It's close, but 0.8, there you go. So your points for this are pretty simple. Did you plug it in? Did you plug it in correctly? And did you get those 3 values to tell me whether or not it's a solution? Did you plug it in? Did you plug it in correctly? Like you used parentheses and you're being careful about it. You got the work shown to do it. Even if you had the calculator do the work for you, you at least showed this number goes here. And then your 3 answers. Okay? That's it. Something out of 5. What? No, this is part of it. This is saying put these numbers in here. That's it. Okay, nice and simple. The idea is an equation is a balance. The balance has to be true. If the balance is true, then you got the right answer, the right solution. We kind of got to know that for today. So, it's been, again, a whole honkin' what? 1, 2, 3, 4, 5, 94 and a half hours since our last visit. I don't know that I had more than 1 question on the homework. I think it was more a question of, do I have to do this one? But talk to me, Goose. What you got? Is there anything from the homework that was a little sketchy? Need help with? Or is it pretty straightforward? All right. Honesty hands. Who actually did the assignment? Y'all know you turn those in, right? Okay. You all know that when we get to the end of the semester, I talked about the Good Samaritan option, the whole grade replacement thing that says if you have done enough of your homework, if you've done enough of your notes, if you're doing what you're supposed to, you get a better grade on the final than your grade going into the final. That's just your grade now. That only works if you actually do stuff. Just saying. Okay. Then we have to actually do 1-9. I thought that we did 1-9 already. So we're going to finish that off and then just move into 2-1. What's this? We don't need that one. We need that one. But we're not actually doing that one. We're doing 1-9. Over half. Student folder. 1. Notes. God, you slow POS. There we go. Well, where were we at? 1-8, we did the stuff, estimating the solution. All right, cool. So we're at 1-9. Basically an extension of what we just finished doing. If I ask, is something a solution, I'm asking, is this going to make it true? What did we say when we were doing our expression stuff about plugging numbers in? How should I write that before putting numbers in? Parentheses, okay? So I'm going to say blank is 4 by blank, and because I'm seeing if it's true, I'd throw a little like question mark over the equal sign. I'm saying, does this actually equal this? And you plug in, say x is 3, be careful you're putting the right thing in the right spot, y is 10, and last I checked, 10 does not equal 12, so it asks, is it a solution? Nope. It's that simple. What we're trying to get you ready for is, you remember back in middle school, when we were doing equations, you always had to check them, right? You'd solve the equation and then you would check it. This is just saying, do you know how to check when you get to an answer? It's not enough to say, look, Mom, I did math. There's a number at the end. You actually have to know that it's right number. Okay? You're in one of the few classes doing one of the few content areas where you can actually make sure every single time that you're right. How cool would that be if you were in the middle of a physical science test and you could make sure that writing Higgs boson is actually correct? String theory, particles that don't exist, they make it up to make themselves feel better. But anyway, you won't get that in physical science. You'll do it in physics. Just this. Can you plug this in and show yourself that you're actually right? Well, there you go. You have 4 sets of numbers. Plug them all in and tell me, are they a solution? Will they actually make this work? Go. Yo.
Science, you said you were a teacher for that one?
I said if I took 2 more classes, I'd be certified for it.
Do you know if they teach like string theory or like Big Bang theory and theories in our school?
In our school, no. However, if it's something that interests you, go talk to Mr. Spear about BH's Math Circle, where they actually will go over to BH. They'll like meet at the school. Everyone hops in the creepy stalker van. You all go over to BH, or you can just meet them there. And you attend one of their Math Circle lectures where they will talk about weird stuff like that. Like, you can prove that infinity is finite. And just weird, weird stuff. There's some smart people over at BH. It'd be cool to go talk to them. Oh, nice. Yeah. Lands are lands, bud. Now, if it was a sealed black border beta lands, yeah, we'd want to hold on to it. But okay, plug each of those sets of numbers in. Tell me if it works. If you need to grab a calculator because you don't know off the top of your head what 4 times a thing is, well, grab a calculator. Okay? And remember, as long as you're following along, you don't have to worry about writing anything. We'll just, I mean, you're here, you're doing the thing, you're good. So I'll just go in and I'll just check those off in the grade book. Okay? Yeah, as long as you're paying attention and doing what you're supposed to, you're good. Plug them in and see if it works. Yes or no. Watch your signs, too. Because 100 is not negative 100, says my bank account. Okay? So I take this and I say, does this equal this? Does this equal this? Does this equal this? Also, make sure you're plugging in the right thing to the right spot. X's go for X, not the other way around. It's really common for kids to see this and accidentally put negative 20 here and negative 5 here because, well, it was first and then second. First and second in the equation, first and second in the coordinate. You all remember what the coordinate is, right? Suppose I didn't explicitly talk about that. You all remember x comes before y. When I'm graphing them, x tells me left or right, y tells me up or down. If that's one of those things that you look at, they're like, oh, instead of, yeah, duh. You know, if you have that little bit of disconnect where there's a little fog around it, maybe you should write that, just in case. You know, just help yourself out. In there I will plug. Put a 20 in for a y, a 5 in for x. Last I checked, 20 is indeed 20. So that one is a solution. Plug a negative 20 in for y and negative 5 in for x. Negative 20 is negative 20. Yay, I'm right. But negative 5 here, negative 20 here. Negative 5 is not negative 80. Not even close. Okay? Like one of those oh so famous speeches that you have gotten. A 0 is not a 40. Right? Have you given the speech yet? Oh, okay. You will get a famous speech that everyone in this school has heard 50 times. That, y'all hand something in. Doesn't matter if you only got like 2 things written out of 5. Turn it in. Because a 40% is not a 0%. It might make or break the difference. I'll rewind you back 6, 7 years. I had 2 gentlemen in Algebra 1 that made a joke out of who could do the least amount of work. Okay? And these 2 would have a little competition about it. They would always rag on each other like, dude, you did like 6 problems out of your 20? What a loser. While the other guy's sitting there with nothing. You did work. You suck. And they thought it was funny. Y'all remember day 1 when I said that I don't round on the syllabus? One of those folks, a fellow by the name of Dawson, got a 59.96% in algebra. You know what passing is? 60. I don't round. He had to take the class over. I did the math. If he would have turned a single assignment in late and got a 3 out of 5 instead of a 0 out of 5, one assignment out of like 70, he would have passed. Okay?
Yes, it taught him a lesson.
It taught his whole grade a lesson.
Exactly right.
Yes, it did. Negative 5 is not 80. Owing someone $5 is not owing someone $80. Okay? 6 and 1.5. Dawson was actually a pretty cool guy. Like, he woke up. He grew up a lot after that. He was a pretty good guy. 4 by 1.5. What if I just don't know that? Grab a calculator. Is it? Yeah. Okay. Okay. Could I do 4 times 1 plus a half? Do y'all remember distribution? Okay. Isn't 4 times 1 4 and 4 times a half 2, so together it's 6? Just like we did with our compatible numbers the other week? So, I forget which class is which right now because I'm teaching everything from algebra half through pre-calc. So, I don't know what's I told you this for the first time and what's I reviewed this with another class. Okay. Using tables. We're going to do a lot of this in here where if I need to graph something and I have no freaking idea how to graph it, you can graph anything by table. So, Carrie and Kim, sounds like Kardashians, were both born October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between their age in different ways? Meaning, what if I had, here's going to be, let's just call it X and Y. And I'm going to say X is Carrie and Y is Kim. And I'm just going to start throwing a bunch of numbers at it. Okay. So, Kim was born 2 years before Carrie. So if Carrie is, I don't know, 6, little kids, little squirts. How old is Kim? Okay. If Carrie is 7, Kim is. If Carrie is 3, 5. Right? You just fill it in. Fill it in with numbers. 4, 6, 8, 10. And then plug them in. If I go to 6, 8, remember your coordinates. X, Y. If you don't know them off the top of your head, maybe we should label that axis so we don't screw up. Okay? Do the X, then the Y. Go to 6, 8. 1, 2, 3, 4, 5, 6, 8. Go to 7, 9. 7, 9. Go to 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Go to 4, 6. Go to 8, 10. Okay? Now, Tommy, what did you say back there? You start making slope. It's a ratio. Technically, we're going to get these later. Well, I just made a table. I also made a graph. Could I write this as an equation, as a balance? We said that Y, Kim, was always, what did I do to Carrie's age every single time? What 2? Plus 2. This is the trifecta. As a table, as an equation, as a graph. Okay? It's called multiple representations. If I can remember right, I got a little matching game with these that we can do maybe a little bit later, probably after we do a little more work in probably chapter 3, I think, where I give you different tiles, and it's like, here's the table, here's the equation, here's the graph on separate tiles. You got to match them. Could you find the table that went with the equation? Could you find the equation that went with the graph? You got to do a little bit of problem solving, a little bit of reasoning. Okay? So, do exactly what we just did. Get a table. Say, here's X, here's Y. And you know, while we're at it, let's just make sure everyone's using the same thing. Will run 6 laps before Megan joins him at the track. So we'll say the first one is going to be Will. And then Megan. I would like you to fill out the table, plot the points, and, tougher part, can you write the equation? Okay? Argue it with your neighbors. We kind of scrambled you up like eggs here. I know you might not be sitting next to someone you normally work with. I don't care. Talk to them. Oh, we're out of that one. Ding, strawberry. There you are. So if Will runs 6 laps before Megan even joins him, how about when Will has done 6, how many has Megan done? Okay. Could I just keep going from there? 7, 8, 9, 10. Megan has now done. It says they're going to run at the same pace. That's important. Because what if we said Megan runs twice as fast as Will? Well, now it would be he ran 1 lap, she ran 2. He ran 1 more lap, she now ran 4. So that would change things. But it says they run at the same pace. So 1, 2, 3, 4. Plot your points. I have at 6, 1, 2, 3, 4, 5, 6, 0, 7, 1, 8, 2, 9, 3, and 10, 4. Good buddy. Hey, you know this graph here that just has X and Y on it? Looks a little barren. What is X in this problem? It's just will.
No,
X is will.
it's the amount of laps Will has ran.
There you go. Labels matter. Case in point. Keely, you want 5? You want 5? Cool. 5 detentions. I'll talk to Bella and we'll make sure that you're all set up. You just go there for the next 5 days. It'll be cool. Okay, Cohen, you want 5? Sure. Okay, 5 Pop-Tarts. You just go in there, dig in, whatever you want. No, I'm broke. Don't take my Pop-Tarts. Pay for them. Okay. Labels matter, right? If someone says, "Hey, buddy," versus "Hey," and just drops bombs on you, okay? Well, maybe your friends do talk to you like that. I don't know. I mean, real friend, you're not really. I was not accepted into my wife's family until her mom called me a little, like, just went off on me. Okay, you are now one of us. Labels matter, so please make sure you put the labels on here. This is laps Will ran. This is laps Megan ran. Hey, I don't see any numbers on here. How do I know that this is 6-0 and not 120-0? Maybe I should put, this is the number of laps that Will ran, and maybe I could just plug on there 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Y'all remember this? It's not enough to just, I got dots on a graph. You have to tell me what the graph means. Give you a pretty good example. Oh, wait, we need the equation. How do I write that? If I say y is Megan, what do I always do to Will's laps to get Megan? Lies. Subtract 6. Right? Now, let's say you said add 6. Every one of these should be a solution, right? I should now be able to plug this in and it be true. So I would say 4 is 10 plus 6. Wait, that ain't right. And then you adjust your equation. You say, no, it's not 10 plus 6, it's minus. Oh, that's right, I need to turn this into minus. Okay? So that's actually a good way to check yourself before you mathematically wreck yourself.
X equals y plus 6?
Yes. Well, it's the same thing, and we're going to get into this over the next couple lessons. Couldn't I now do minus x, y minus x is 6, subtract y, negative x is negative y plus 6, negate the whole works? You can start monkeying around with letters and numbers. That's solving equations. Okay, so we'll get there. But for now, yeah, that's cool. When I say that the scale matters, there's a pretty famous graph that went around, about 18 months ago that said Ladies and gentlemen, we have flattened the curve. Let's open up for Memorial Day, and who cares if you have any form of medical disability? You'll just die and save us taxes. There was a very famous graph that went around like this, and people were using it to justify policy decisions. The scale of the graph was logarithmic, meaning it went by a base. 100, 1,000, 10,000, 100,000, million. So when we said, oh, hey, look, we flattened the curve, that meant that like 800,000 people a day were getting it. The labels on the graph matter. So please, whenever you're making a graph, put labels on there, because it kind of matters a lot. That's also why we teach you this stuff. A lot of kids will go through high school and be like, why do I even need to know this? You need to know this so that when someone puts a graph in front of you, you aren't taken advantage of, or you aren't led to believe something that's not true. Okay? How many of you have heard, you've been watching TV, maybe a YouTube ad pops up and it says, #1 truck in America. Don't they all say they're the #1 truck in America? Every single one of the brands. The labels matter. You look in the itty bitty tiny little print at the bottom of the screen, and it'll say #1 in domestic sales, #1 in consumer satisfaction, #1 in consumer retention, #1 in. They all are #1 in something, but what are you doing? It's like, okay, my son, he's 2 now. He does this. He's a flasher. Like he'll just walk around lifting his shirt up all the time. Sure look like it. So, okay, we crossed there. Extending a pattern. You know that patterns are used for intelligence testing because a dolphin can find a pattern. A monkey can find a pattern. I don't need to know anything about math to look at this and say, what's happening every time? What do they do every time? To go from here to here to here. What's changing? Adding one what? One block, and those blocks are all the same, right? They're not rotating. It's not like this, and then now the purple ones are this way. It's just the same thing. Again, one big block, 2 big blocks, 3 big blocks. Table shows relationship between the number of, oh, all right, I should probably turn it back for this. If they're going to talk about a specific color, I'm guessing not many of you know what the inverted color wheels are. Like, what's the opposite of red? You sure? Well, what's the opposite of blue? No. I want you to take a look at that right now. I want you to stare hard at one of the blue rectangle or blue squares. So that's why I'm putting it back like this, because I do too. This hurts my eyes. But we're going to use it to get through this. Okay. Table shows relationship between number of blue tiles. Okay, so those are the center ones. And the total number of tiles in the figure. So right now I see 1 blue tile, but there's 9 altogether. I see 2 blue tiles, but there's 18 altogether. I see 3 blue tiles, but there's 27 altogether. And then, if I see this pattern, could I keep going? What are they doing every time to the number of blue tiles? Adding 1. What are they doing every time to the total tiles? Adding 9. So I can use that to keep this going. What is the total number of tiles in a figure with 8 blue tiles? well, maybe I can turn this into an equation now. What do I do to this number to get this every time?
Multiply it by 9.
So I could say, here's x, y is 9 times x. I'm getting to equations now. So if they say, what is a figure with 8 blue tiles? Now I know it's y is 9 by 8, because 8 is the number of tiles, 72. Okay? I can take a pattern that's literally just, here's a bunch of colored blocks. I can count. Yay! And I can turn it into an equation. This is actually the genesis of math. This is where it came from. Is someone started recognizing patterns and counting things, and they started putting symbols with it, and symbols had ideas. You know that's how our language is? You know that the meaning behind words changes all the time? For example, it's starting to fade. If someone your age said pog,
What?
pog, pog, P-O-G. Okay, yes. What does that mean?
I have no idea.
Or am I already 2 years behind? Okay.
I thought it was like a tug myself, like the dot.
Versus someone who's 36 says a pog.
What's that? What is
Pogs were an actual game. You had a bunch of cardboard circles and you would stack them. They all had different pictures on them. And you'd have a pog slammer and you would on top of the stack and you'd knock them all down. Whoever got the stack down at the end with the most pogs in their hand wins. Very simple. Okay? But that word confused the living crap out of me when kids started using it. Because I heard, oh, that's a pog. What? What? Why? Huh? Okay.
What does it mean now?
I don't know. You guys change your meaning every 6 months. I get a new vocabulary every semester with kids. Okay? So, the meaning of the word can change. The meaning of a symbol can change. That's where math came from. Someone said, you know, math is all numbers. It's all just counting and adding and subtracting. What if I got sick of that and wanted to replace it with an X? A letter to say, this means an idea. I changed the meaning of X. It is no longer just the letter. It is, okay? You can change the meaning of a thing. I would like you to do the same thing, but from this same figure, make a table showing orange tiles to total, and I'd like you to make a graph to go with it. So we did a table. Now I want you to do the table with a graph, just like the last one. Can you use this table, this information, to extend the pattern out? Yeah, just somewhere down at the bottom there. Oh, it is part A and B. So you're going to have 2 different tables. You know what? Just make the tables. I'll put the graphs up there. I'll put the graph up there. You make the 2 tables. Oh yeah, that's the very end of it. So just anywhere down there. You're good. Yeah. Well, look at the table right above that. Look at the big honkin' orange table right there. Do that for the stuff they said. Okay, for Friday, we're going to need at least 50 of each. For the October event, we should have about 200 of each.
Yep.
So Yep.
Answer. You like him?
You look like the lifeguard from Sandlot.
The chick?
Yeah.
Whoa.
The guy goes and like fakes drowning so that he can make out with her.
What was her name?
Wendy Pumpernickel or something.
Yeah, Wendy
Wendy.
Peppercorn. Peppercorn. I love that you guys have actually seen that movie. That makes my old heart happy. Thank you. Stop laughing. Shut up, Oz. Okay. So part A, make a table showing the number of orange tiles and the total number of tiles. So I'll say orange to total. And fill it in. Well, how many orange are in this one? First of all, is there anyone here who is actually colorblind or has different levels? Suppose it's not a fair question to ask. This. Okay. Because I've had kids in who can only see in certain colors. I had one a couple of years ago. She could only see in varying shades of blue and yellow. I had one a few years ago who couldn't see the color purple. Purple just didn't exist. If I were to come up here and write with a purple like this, it didn't show up. She just legit did not see that. So there's no one in here who has any sort of color variation for their vision? Okay. So, orange. If there's 4 out of 9, then the next figure says there's going to be 8 out of 18. The next figure says there's going to be, keep it going, out of 16 out of what? Because then we go to 54 with 24. Okay. Make a table showing number of blue tiles and the number of yellow tiles. So now it's not to the total. Now I'm going to go blue to yellow and say there's, well, this one's easy. 1, 2, 3, 4, 5, 6, 7. Right? Only one in the center of each. Yellow. Start with 2, then 4, 6, 8, 10, 12, 14. Okay, it doesn't ask for that, but could you now tell me what those are as equations? Okay. Y is what times x? What do I multiply 4 by to make 9? It's a fraction. What's up?
So was it 9/4?
9/4. Look at this guy. Yes. It's pretty easy where if you think about it the other way, you'd say 4 x's is equal to 9 y's. Or no, the other way around, Wow, I'm tired. You know that I made your notes last night at like 1 a.m.?
Oh wow.
Yeah. What about this one? This is a little bit easier. What do I do to the x's to make the y's? Multiply by 2. Okay. Pretty easy, right? That one's better, not fractions. So, yeah, just cross out the graph. We're good with just tables. I think you know how to plot points. If you don't, we're in trouble. There we go. Make that go skadoosh bye-bye. Yep, we got time. We're going to move into one. I'm pretty sure we can even finish it too because it's all one-step equations. Really easy. All right. I would like everyone in the room, look straight forward. Straight forward. Turn your head 90 degrees to the right. Turn your head 90 degrees to the left. How many of you are now looking to your left instead of straight forward? Gotcha. What happens if I go 90 to the right and then 90 to the left? You're right back where you started. Okay. You see how many freshmen are just like, huh? That was great. Okay. All right. I'll let you do that to your teachers.
Okay.
Okay. Go tell your teachers, hey, we did something in math. I want you to see if you can follow instructions. Or not even follow instructions. That tips them off. Say, we did something in math involving degrees. Can I like write yours down or your results? And see how many of your teachers do it wrong. It's hilarious. You want to mess with how many of them are not original, like basic pumpkin spice latte, Becky, basic. Okay. Right now, every one of you. Oh, I need a. I'd like everyone in this room to pick a number between 1 and 10. Go. Got it?
I guess 7.
Who picked one of these two numbers? Wow, a little more random this time. Okay. Human beings are horrible random number generators. If I say between 1 and 10, the majority of people will avoid 1 and 10 as the extremes. They will consider 5 and move away from it because it's in the middle and it's too obvious. So they'll go for quartiles at 3 and 7. Like, just, that's psychology. Do that to your teachers. See how many of them are basic and choose 3 or 7. Who in here picked a non-integer number? We did number sets, y'all. Like, integers are -3, -2, -1, 0, 1, 2, 3. Who picked a non-integer number? Who picked 4/3? Who picked pi?
Me.
Okay. Did anyone pick a non-integer number?
No, not that.
Oh, okay. Quiet, you're not in my class. So, the whole idea of the 90 thing is, if I turn 90 to the right and then 90 to the left, I'm right back where I started. Those are called inverse operations. One undoes the other. If I told everyone, raise your right arm, put your right arm down, you're back where you started. Those are inverses. So that's what we use to solve equations. The opposite of add is subtract. The opposite of subtract is add. The opposite of multiply is divide. The opposite of divide is multiply. What's the opposite of squared?
Square root.
Square root. What's the opposite of cube root? Cube. Cube squared.
Square.
11 blue. Okay. All right. So that's all that this is. If you read through it, it's just saying I can undo subtract with add. I can undo add with subtract, and on. We're not going to go hard on this because we're doing 2 lessons in one day and they're both fairly simple. It's just one-step equations. But it's more about the format. I want you to get used to writing it out. I don't care if you can do it mental math because I'm pretty sure that we did by mental math last time what plus 13 is 27. Okay? Now when you say what plus 13 is 27, How many of you actually count out? 14, 15, 16, 17, 18, 19, 20. How many of you count to 27 versus it was easier to do 27 minus 13? That's the inverse operation. Y'all remember writing it out fully? The opposite of plus 13 is minus 13. Do it to both sides. Show that 13 minus 13 is 0. Drop the x because I haven't touched anything yet, and then call it 14. Does that look familiar? Like the full process. Could you just do it in your head? Could you just say 27 minus 13? Yeah. Could you type it on a calculator? Yeah. Write it. You are more accurate when you write it out. So please, write it out. Now, next to it, it's going to say, check your answer. When we have baby steps like this, it's not too hard to do this by mental math, but I still want you to get in the process of writing it out. If I said x is 14, I should be able to say 14 plus 13 is 27, and it better be true. This is more about getting used to the format of writing them. Everyone, I don't care how smart you are, I don't care what your level of ability is with mathematics, everyone runs into the wall eventually. Everyone hits the point where you just don't get it anymore, where you can't do it in your head anymore. Everyone. Okay? So we're practicing writing it the correct way now so that when we get to the tougher stuff, you have a format to fall back on. If you don't do the drills in practice, you're going to suck in the game. Do the drills now when it's easy, when I know how to undo things. Your go. Write it out correctly. Okay, write it out. Not those. Those are pre-made kits ready to go. That was actually supposed to be for our spring break weekend tournament right before shutdown. Okay. Should be pretty fast. Y plus 2 is negative 6. I undo add 2 with minus 2. But I'm actually going to write it out and say 2 minus 2 is 0. I haven't touched y yet. Y is negative 8. And go back and prove that I'm actually right. This plus 2, does it actually equal negative 6? Plug in the negative 8 that you just said. I should now have negative 6 equals negative 6. Okay? This is more about the format and the process of writing it. I know you can most likely do this in your head. Okay? I know you can probably do it in your head. But we need to write it out like this so that when it gets ugly, we got the right framework. Okay? It says, why does subtracting 13 from both sides result in an equivalent equation? Okay, let's come over here and say, y'all been on teeter-totter, right? We have here a teeter-totter. We got these two on one side, we got these two on the other. And everything's nicely balanced. It's perfect. Okay? What happens when Booger decides to jump off?
She gonna go flying.
Okay? Trey and Grace are going to be, boom, right down on the nethers, right? We've all been there. Everyone in here has gotten the teeter-totter slam, okay? Pop it, go boom, okay? If you subtract 13 from one side, you have to do it to the other because it maintains the balance. How many of you have done, does anyone do different types of weight training? Anyone do like farmer lifts where you just grab dumbbells and you're just supposed to grab them and walk, just walk. Okay, have you ever tried to grab those weights but only on one side?
It's like here in the middle. Go follow me.
Okay, and you're supposed to clench your abs on that side to maintain your core. Okay. I used to be coach and PE teacher. Don't let the 5 years, 2 children, and 60 pounds fool you. Okay. You would do those things because it would maintain that balance, right? If I was only carrying a weight over here, it's really hard. You're going to fall over. You have to do the same thing to both sides to maintain a balance. That's why it's actually a good workout to do it with only one. So, what if I am, oh no, whatever shall I do? It's not adding now. Pretty sure you all know what to do. Add 3, add 3. Okay. Now, I get the rare privilege, boy, I'm tired. I get this weird duality of seeing you here in Algebra Half while also talking to kids in Algebra 2 and Pre-Calc, where some kids get taught by a teacher who is just adamant about controlling things from middle school. How many of you were taught this is just wrong because I didn't write it like this? Who here was told you have to have the variable on the left? Anyone? Does anyone just feel weird if it's not? Okay. So technically these are both the same answer. They're both correct. We usually say B is, not this is B. Okay? They're both correct. I'll take both. You're good. Whatever. Same thing. Go back, check it. -7, is that really -4 minus 3? Sure enough, -7 is -7. It doesn't take long to write it out. I just want you to get in the process of writing it out. You notice down here, you get, you might have positives, you might have negatives, you might have fractions. Go for it. Can you do it with fractions? In this house, we write our answer as fractions. Okay? I don't know. Can freshmen take debate? Oh, yeah, that's right. We had talked about this before because there was only one of you. There's something called precedent. In this problem, that is written in fraction. So you got to write your answer in fraction. Now, if it comes out as a whole number, great. But we don't go to decimal land unless the equation already had decimals in it. Okay, write it out, show the steps. Show that -8 plus 8 is 0. If you get on that particular train, if you're doing it that way, we're less likely to screw things up later. Here, get back over here. Okay, say +8 plus 8, m is -6. Go back and check it. Is -6 minus 8 actually -14? Use your calculator if you need to. Yay, I'm right. If they subtracted 3 halves, I'm going to add 3 halves. Show that it zeroes out. I didn't show that over here. And say y is, what's 3 waffles plus 1 waffle? 4 waffles. Lunch. What is 3 halves plus 1 half? 4 halves. And which is 2. Okay. So we said y is 2. Come along, and 1/2 is that 2 minus 3 halves. Okay, that's one that you might not know off the top of your head. If you can turn it into, remember, this is over 1 times 2 times 2. Call that 4 halves minus 3 halves. Great. If not, I'm going to run things a little bit different than other teachers. This line right here, I got no problem with you just typing that in a calculator and actually coming up with a half and saying, cool, I did it right. Okay? You're big kids now. Do I want you to write it out? Yes. Do I want to deprive you of the tools? No. No. I want you to use the tools. We only took away the calculators one day. I will never do that again. So, same thing with multiplication and division. I undo add with subtract, I undo subtract with add. I'm going to undo multiply with. What I would like you to do when you show this, what is 4 divided by 4?
1.
Show that it's actually 1. That is now 1x. Now maybe I don't know off the top of my head what 6.4 divided by 4 is, but I bet Ashton, since he has his phone in his hands right now with a calculator in the apps, can tell me what is 6.4 divided by 4?
6.4 divided by 4 is 1.5.
Nope.
0.1.
Nope. Nope. Busted, Haas. Said, I got no problem with you using your phone as long as you're doing what you're supposed to. You weren't doing what you were supposed to. Okay? So, 6.4 divided by 4, anyone else with the actual calculator in front of them, or 1.6. How about, do you know what 64 divided by 4 is? And then, because there was 1 decimal point in the problem, there's 1 decimal point in your answer. Take 16, move the decimal over. Okay? Do the same thing here. Get them. Remember, if they have decimals in the problem, you are allowed to go to decimal town. If they do not have decimals in the problem, you write it as a fraction. Simplified fraction. If you're more comfortable writing that way, do it. I undo multiply with divide. 10 over 15. I don't see a decimal there, so I have to write my answer as a fraction. I will reduce it. What do 10 and 15 have in common? So, 10 divided by 5 is 2. 15 divided by 5 is 3. It does say to check my answer, so off to the side. I say 10. Does that really equal 15 by x? And I said that x was 2/3. Y'all remember how to do this? 15 times 2 is 30. 1 times 3 is 3. That's 30 over 3. Does that really equal 10? Okay. I'm assuming you know how fractions work, or you got a calculator that's going to fraction for you. I would rather you knew how fractions work. Next up, I undo negative 3.2 is hugged up on z, so I split them up. No homecoming babies. And we say 14 divided by negative 3.2 is... Yo, I'm running on like 4 hours of sleep. I don't got the mental mojo to do that right now. Press the buttons. 4 point... Is it actually 0.375 and stops? Or does it keep going?
Actually, it's done.
Okay. In that case, 4.375, oh... What's positive divided by negative? Negative 4.375. If it's a terminating decimal and they gave me decimals, go ahead. That's fine. You write the decimal. But don't cut it off, is what I'm saying. It's like, if you called that negative 4.4, all right, that's wrong. You rounded something. You lost part of it. Like, you all have a calculator in front of you right now. What if... who's got a job right now? My God.
We like money.
What is the world coming to? You're a little too young to be working like this. This is child labor. All right. Haven, where you work? No joke. So that's like all the old people, and you get really good tips. Or are you the little bum who has to come out and clear off the tables?
They're the one that get tips.
I'm
Little
the-
bums.
Yeah,
The little bums
bus
get
boys.
the tips.
No, those are supposed to go to the waitress.
No, we
They
get
have to-
percent.
they have to
They
get
give
like
us
a
how much we
percent
get. I come away with like.
No,
7.
okay. I learned something today. Let's say you're at, do you mind saying, what is your wage?
Oh, for what? It's different for
Yeah,
busing, dishing,
dishwashing,
and hosting.
busing, and hosting.
Man,
Dishwashing,
y'all are-
13, busing 10, coaching 10.50.
Wow, they really screw with you. Okay.
You stand.
You walk in tomorrow, they say, we're not doing that anymore. We're going to make it easier by just offering you $10.15 an hour flat. Done. Doesn't matter what you're doing, $10.15 an hour. Okay? But, sounds like you work in the same place. Okay? They're going to offer Trey $10.40 an hour.
That probably happened like this.
Okay. It's not much, right? What's the difference from $10.40 to $10.15?
Whoa, 10 cents.
Not 10 cents, 10 cents an hour.
Okay, then the manager realizes that Trey can't do basic arithmetic and offers Trey $9.95 an hour. Okay? What's the difference from $10.15 to $9.95 an hour? 20 cents. You say 20 cents isn't a big deal. Y'all got a calculator right next to you. Type 0.20 times. Let's say you do 20 hours a week. It's $4. You're like, big whoop. It's like 20 cents, $4, big whoop. Take that times the entire length of the school year. Take that times 40 weeks.
It's like $160. 160.
Okay?
I feel it, though. I started making an extra.
That's like-
I get like an extra $100 per paycheck.
You could buy a used Switch for that.
Why would you want
Because I'm not rich and I can't afford a regular one on the store.
You're not going to buy a Switch
like
Why not?
because you don't like consoles.
Okay, I won't because I have a problem. Okay?
I'm sitting here looking at cardboard. You think I don't have a problem?
That's true. Okay. Long story short, I haven't owned a console for something like 11 years because I kind of forgot my wife's birthday one year. So I tend to fixate. You know, I will go to bed at like 9 unironically because I'm just tired. You put a controller in my hands, it's like 4 in the morning. So, but anyway, the moral of the story is the difference in that little bit of decimal. That was the difference in 20 cents. The difference from 4.375 to 4.4 might not seem like much. But what happens when a business does that to 100 customers a day, 365 days a year? What happens when a business, like, have you ever seen some of the gas pumps that are saying it's like 348.9 per gallon? You seen those?
Yeah, that's so.
Okay, and 9/10 of a cent. Okay. Businesses will use things like this, and they'll take that tiny fraction, that little bitty decimal that you're not willing to write. Stop it. They'll take that itty bitty decimal and they'll just kind of keep it for themselves. Well, what happens when I'm talking about 1/10 of a penny to Jesse? I don't care. It's 1/10 of a penny. I don't even know how to cut a penny in tenths. Who cares? But what happens when you do that to 200 million people today? Nationwide. Okay? It really adds up. So what I'm getting at here is if it's a decimal and if it terminates, it is done. Go ahead and write it. But if it does not terminate, if it keeps going, what if that was 4.377777777777777? Oh, gross. No. Don't do that. Bad. Y'all know where the change to fraction button is on your calculator?
Mine's an S to a D.
Okay. Everyone should have it. I gotta wait for Frank here. Frank is really slow. He's not too bright. Come on, Frank.
Oh, he's slow. He's just slow.
Come on, Frank. That's actually a thing. It's called processing speed. Like human beings have different processing speeds.
How can you tell what it is?
Accurate psychological assessment.
Yeah, what's that?
Run you through a bunch of tests that are normed against other people's abilities and responses. And I determine whether you're normal or not.
Oh, let's do that on Thursday.
Oh,
I don't think you want me to tell folks if you're normal or not. So I'm going to come all the way back here, and if I have that 4.377777777, you can just 4.3, and then we'll see how long Frank takes to catch up. That's it. Frank can't do regular, much less auto. Come on, Frank. About done there? Okay. On these ones, math. If you got a graphing calculator, math, option, change fraction. You just spam the number a whole bunch of times, and then you hit change your fraction, and it'll do it for you. Okay? Everyone find that button on your calculator. You need to know where it is. It's such a good help. Now, for you, it might be somewhere else. I've seen ones that look like FD, and they have this little like arrow in between them. I've seen SD like this. I've seen just a straight up convert button. Like everyone should have something like that. No, that changes things into your memory. Everyone needs to have one. Store English. I have no friggin' idea. Oh, it's one of those catechisms. Where are people picking these things up? This is like the fourth one of these I've seen, and I've never seen them before this year.
goodness sake.
Huh. All right, I'd have to play with it. Yours SD right there. Bam. Nice and easy. Is there anyone who doesn't know where theirs is?
I don't. I didn't find mine. But
Okay.
just kind of
You have a. Where's your? It's in a secondary feature.
Okay.
So if I had 4.3 on 4.3, you spam your sevens. You say, I got no idea what this is. Second, F to D.
Okay. Thank you.
Okay. Okay, you got that Kataga again. I have no idea what these things are. I've never seen them before this year. I need to play with it later. Okay. Well, you should have a user manual or just Google it. Same thing. Spammed it, and then second, right above here is F to D. So you have to do a secondary function. Okay. But you should actually want your cursor in the end, not at the beginning. Because now it's trying to say 4 changes to a fraction, 3 to D. Casios, those are nice. They just got a S to D. I like those. Anyone else? You're running the 84s. It's exactly what I did up there. Hit math. Change to fraction. Option 1. Okay. So just got to make sure that everyone knows where the buttons are. Okay. Y'all cool with this? Multiply by the thing, divide by the thing. Press the button. What does this say? Suppose I didn't do the one before. I just thought there was numbers there. What does this say? X over 4. But what operation is that? Division. So I undo divide with multiply. Maybe it's more familiar if I write it like this and then say take this times 4 over 1. Take this times 4 over 1. Because the 4's will cancel, now I just have x. Okay? No. Now if I think that x is negative 36, go back to the original, negative 36, over 4, and is that actually negative 9? Yeah, negative 9 is negative 9. I win. Do the same thing here and here real quick. If they say divide by the thing, I undo it by multiplying by the thing. Okay, it's not hard. It's not rocket surgery. Okay? Just show that those 3's will cancel. Show me that this times a negative 9 and this times a negative 9 cancels and equals negative 72. Show me that negative 72 over negative 9 is 8. It doesn't take a lot. Okay? For some reason, kids just hate writing. They think if they write that one more step that they're going to develop carpal tunnel early. Don't worry about it. Okay? You won't. It takes a while. Reciprocals. Oh, no, you ever heard the words? Dividing by fractions is easy as pie. Flip the second and multiply. If I'm taking 4/5 times m, I can undo multiplied by 4/5 by dividing by 4/5. Dividing by 4/5 is the same as multiplying by 5/4.
Are you playing with the children again?
I got you.
Stay on the bench, Haas. Okay. 5s, cancel. 4s, cancel. So just m is 28? No. What you do to one side, do in the other, times 5/4. Do y'all remember cross cancel? Since 5 and 4 don't have anything to reduce, 28 and 1 don't have anything to reduce, I start looking kitty corner and I say, do 28 and 4 have anything come? Yeah, divide both by 4. That's a 7, that's a 1. 1 by 1 is 1, 7 by 5 is 35. So I should be able to prove this now. I should be able to say 4/5 of thing is at really 28. Y'all got a calculator? Prove it. Is 4/5 of 35 actually 28?
Yeah, it's valid.
It's valid. Okay. I could also cross cancel here and say 28 is 28. All right. Just got to show the check. If you need the calculator to do the work for you, that's fine. Your turn. Get it. Here's them. Will do. Yep. Office after class. Not you. You. Yes, Dylan. Okay. Oh, thank you. Just go talk to Pam. It's probably just something with were you actually in this class or not. Oh. Solution of this. If I say 12 is 3/4 x, how do I undo it?
Multiply by 4/3.
Okay. If I take this one times 4/3 and this one times 4/3, show that those cancel, getting just x. Now I can cross cancel. I could also say that's 48/3 and then turn it into 16. That's cool. Or you can cross cancel and call that 4 and 1. Still, 4 times 4 is 16. 1 times 1 is 1. It doesn't matter which way you take. You can cancel before multiplying or multiply then reduce. Same difference. Either way, I said the x was 16. Go back and prove it. 12, does that really equal 3/4 of 16? Grab a calculator and double check it. 12 and 12, yeah, same thing. Next up, they ask, are these two things equivalent, yes or no? How do I know? M equals 18. This is asking the question. Jesse, what's your name?
Yes.
Oh, cool. M is what? But then I told you what. I'm pretty sure M is 18, right? So they're saying in the other one, if I plugged M is 18 in there, would it be true? Is 2/3 of 18 12? Grab a calculator. Or maybe a little mental mojo. What's 1/3 of 18? 6. So what's 2/3 of 18? 12. You double the 6, right? So because both of them are true statements with both of them having M as 18, that means, yeah, they're equivalent. Oh, I take it we're all done?
Yeah, we was packing up. I did.
Well, I guess you can do the word problem stuff on your own. Okay.
It was fun.
The word problem example needs to be finished. You can find out real quick. packing up before we're done when it would have taken another 45 seconds, I don't care. That is still requisite. You will still have that example done. You will still do those problems.